started there. So I'm delighted today to welcome Ricardo Ferreira, who's going to talk about leveraging digital solutions for transformative water asset management. Ricardo was a finalist at the Asset Management Excellence Awards in 2023 in the Next Gen Award category, and I had the pleasure of sitting next to Ricardo at the awards dinner in December, so it really is a pleasure to welcome him back today. I'll let Ricardo introduce himself briefly in just a moment, but before I do, I'd like to remind you that we will be taking questions at the end of the session. So if you have any questions you'd like Ricardo to answer, there will be a QR code which will access Mentimeter for you, and Ricardo will share that as part of his presentation. So thank you very much, and over to you, Ricardo.
Thank you, Miranda. It's very nice to be here with you all, and I hope you enjoyed the webinar that I will be delivering. As Miranda said, it represents the project that was submitted to the Excellence Awards for the Institute of Asset Management, in which I was a finalist on the category of the next generation. So without extend much further, I will start the webinar. So, as I said, good afternoon, everyone. I work in the asset management department at Águas e Energia do Porto, and our daily work aims to achieve a holistic balance between technical and financial optimization for our assets and the investment plan of our company. We strive to ensure that our investments are sustainable, and focused on critical assets. And this project illustrates the journey that ADP underwent in embracing digital transformation and leveraging data as a service tools to revolutionize water asset management. The digital investment and integration of our physical assets with our digital parts have resulted in significant improvements in risk analysis, decision-making process, and overall planning. Before we commence, let me brief you Águas e Energia do Porto. Águas e Energia do Porto is the largest water utility in Portugal. We are tasked with overseeing a range of essential services in the municipality, including managing the water supply, the wastewater treatment plants, stormwater, streams, and seafront areas. Also, we're deeply committed to promoting environmental education and sustainability within the community. With such a broad scope, you can imagine the sheer volume and diversity of assets we handle, from numerous infrastructures to a vast array of scales, complexities, and types, whether linear or nonlinear, underground or visible, known or unknown. Our operations cover a wide spectrum. Efficient asset management in such a context is far from straightforward. Our water supply system comprises about 800 kilometers of network, including 6 water tanks, 93 DMAs, serving over 163,000 customers, and featuring more than 350 monitoring points strategically distributed throughout the system. Regarding our drainage systems, we do have two distinct, one for wastewater and another for stormwater. It's worth noting that our city is famous for its ancient underground water galleries, adding a unique dimension to our asset management. We're proud to say that we take sustainability seriously by reusing our wastewater. Through cutting-edge technology, we convert it into water that's not only suitable for cleaning the city, but also for watering the lawns of our city's football club. It's a testament to our commitment to maximizing resources and minimizing waste. And since 2020, we have taken on the execution of the municipal energy strategy as well. Before we jump into the specifics of our work and the outcomes we achieved, I want to take a moment to shed some light on the global reality on the water industry. It's crucial to grasp the difficulties of analyzing and assessing risks in a system that's constantly evolving and is dynamic. Water assets differ notably from traditional infrastructure assets. They represent one of the most valuable and scarce resources on the planet. However, the responsibility of carrying this resource can also pose significant challenges when systems aren't equipped to handle the right amount. So, how can we better control and understand the variables for each specific and independent system? How can we direct the most efficient investment to each ramification of our water cycle assets universe? The answer is by allowing the digital to bring its contribution. Focusing on digital maturity, ADP has reached a stable level, dedicating substantial time to boosting productivity and allowed us to progress and enables to delve deeper into analysis and fully leverage our digitalization initiatives. Today, our operational staff works with digital environments on site. We offer various digital platforms for customer support, and we have implemented predictive models. Now, the presentation of the project will spotlight a crucial aspect of Porto's water supply master plan, focusing on detailed data analysis to extract invaluable insights. Our process involved the examination of a large volume of data with diverse types, focusing on accuracy, timeliness, and the selection of data with substantial real-world value. We're talking about millions and hundreds of millions of data and distributed throughout the information systems that the company possesses. Although ADP have a satisfactory digital maturity, at the project's initiation, all data was exported from the different information systems and stored in Excel spreadsheets. This is a widely recognized data analysis software and that everyone can easily work around. However, due to the involvement of multiple personnel, data stores, and a variety of file sizes, the primary spreadsheet began to falter, placing all the previous work in a critical situation and creating a delay on the project deadlines. Also, because information and analysis types were dispersed across multiple files, the outputs were inconsistent and insufficient due to a lack of connection between them. So, this led us to develop a strong data model capable of handling the extensive data spread across multiple databases storing our primary information. We collected historical leaked data dating back to 2013, initially stored in an effective database, and incorporated it into a specific feature class within ArcGIS. We knew that this was one of the variables to be more attention towards identifying the critical assets within the water supply system. We had customer data, including water meters IDs, buildings IDs, and consumption locations that were integrated into the GIS to establish correlations with our water supply network. We also integrated Porto's digital elevation model data since we knew that the terrain values had a direct impact to our hydraulic expressions and formulas. We gathered operational data from our platform software and included it in our server, alongside data from our flow and pressure sensors within the water supply network. Once all the data storage were defined, we initiated the logical construction of our data model. Nearly all of our relationships were built around our pipe ID. While our initial focus was not asset-by-asset control, we aimed to construct a model capable of delivering asset detail as we moved forward. So we were preparing ourselves to have the conditions to, from now on, have the control asset by asset without creating model specific asset by asset. Don't forget that we have a panorama of our entire water supply system as one asset instead of multiple assets. So, how could we optimize the limits of the existing DMAs? How to analyze the minimum impacts and costs of the network? How could we actually control the pressure and reduce the number of leaks to improve customer pressure levels? We began by creating a model and developing an algorithm to simulate our ideal water distribution system, ensuring optimal pressure citywide. It also outlined the potential for improving and extending our DMAs to address problematic sensitive zones. This model and algorithm was based on existing water tanks location, the network location with the information coming from our GIS models, and the terrain levels from the DEM. We then visualize the results DMA by DMA, comparing them to the current system on the ground. Initially, the difference made us question the model's accuracies. However, after verifying pressure measurements on site, we confirm its reliability. Building on the initial analysis capabilities and the results of our previous model, we embark on structuring a tool designed to provide ground and floor level pressures for each customer. We are talking about 163,000 customers distributed in a very dense city like Porto. So this aimed to determine day and night pressure per customer, identifying the ideal pressure level, and determine the proximity of each customer ID to that ideal level. We're talking about 26-meter water columns. Here we can see the sill pressure tool. This tool enables DMA by DMA analysis, offering control over the pressure being examined, while spotting problematic areas with both maximum and minimum pressures. It further provides insights into the number of affected pipes with their respective IDs and illustrates the pressure variation across the network through the map. Also, by having this tool, we were now able to analyze and compare two separate and distinct assets that normally don't go end around, like clients, customers, and water pipe ID, or in this specific case, the entire water supply system. We knew exactly what pipe was responsible to deliver the water to the customer and the implication that will have on the pressure levels and the quality of the pressure that the customer have. Here's an example of the DMA Nova do Tronco, located on the north side of Porto, showcasing the improvement results achieved through the digital model. If you look to the pressure graph, we were able to reduce the pressure in 25 meters in the night and the minimum night flow reduced at once from 7 to 4 cubic meters per hour. These results were enormous to zone or DMA that was actually critical to our water supply system. Okay, what about leaks? As the project went forward, our attention shifted towards addressing leaks within our system, aiming to boost our asset management intervention plan for the network. Although ADP already has a platform and a software and operational software management, we recognize a few issues within our operational management software, and specifically, they were also related to leak interventions, leading us to begin our efforts there by analyzing all of the history within the operations regarding the leaks. So, since 2017, ADP has been using a management operation platform to collect data from field operations. However, until 2022, the information regarding leaks was not being used effectively, causing a lack of profitability for decision making. To address this issue, we implemented a new procedure. We continue to use our management operation platform to develop an analysis and data cleansing process. Also, we join within the operational team and we have made them understand the necessity of having quality data collected within the site. Then we georeference all the leak information to our GIS ID pipes, and then we finally structured all this information into a user-friendly application, enabling technicians to extract valuable insights within leaks. The biggest goal of this tool is that it is updated from 2022 onwards to reflect all of the network updates once it is connected with our GIS model and all of the other database regarding the information between the software platform and the GIS models of the water supply system. Here we can see the preliminary tool concept. Here we have the first version of the algorithms involved in the analysis, serving as the foundation for the final tool and its associated indicators. The tool incorporates various algorithms that enables to analyze our network meter by meter, allowing us to identify correlations and conditions of leaks per pipe and assess whether the pipe needs to be entirely or partially replaced. As you can see on the diagram, the algorithm takes the collected time data regarding the operation on site and associates it with the historic data of the analyzed pipe ID by pipe ID. In this video, we can see the tool interface, where we can filter the leakage analysis by a specific year. The algorithm delivers the total pipe length that has a history of leaks throughout the pipe length. If we analyze the full leaks history and focus on the second most priority pipe, we can see that the algorithm recommends replacing only a part of its length instead of replacing the total pipe of the total extension of the pipe. It is important to note that the tool does not dictate the technician analysis, but rather highlights potential issues for them to consider. Here is a brief legend outlining all of the tool's capabilities. The implementation of this tool has enables ADP to identify its critical water assets and make informed decisions regarding interventions based on the tool's outputs. The first interaction that the tool gave us, it says, and it delivered a total extension of 3 kilometers to resolve all of the problems within the system regarding the leaks nests. So leaks nest is actually a concentration of leaks and in a zone that we assume and correlate that is critical and has a lot of events of leaks throughout the history in our system. Based on this, ADP started a fast on-site action plan called Urgent Water Pipe Renovation Contract. As conclusions, results, and future perspectives, we would like to adapt all the DMAs to the ideal pressure level. On the left side, you can see the DMA division at the current moment, and on the right side, you see what the DMA should look like if we could divide the network following the terrain elevation in pressure levels with 20-meter intervals. Because of this digital model, we have a strategy to get there, and we work daily to achieve it, already knowing how much it will cost us and the best way to go around. Also, since it reads directly with the updates within our GIS model and therefore our water supply network, it can improve and it also can translate those new information to adapt to the algorithm results. Regarding the leaks and the assets renovation plans, the combination of the contract and the digital tool has proven highly effective. In just 10 months, we managed to eliminate 20% of problematic network sites, addressing critical pipes and leaks efficiently. You can see here the location of the original leaks nests, and after 10 months and currently more than a year, we do not have the same location for these leaks nests. So we were able to determine, based on the correlations done by the algorithm, that the investment plan and the identification of the critical assets were actually very precise. Our progress is visually represented, showcasing how we have reduced the number of critical pipes and leaks. And also, this stretch's impact extends beyond assets improvement. We have addition of new data periodically, instant acting time, and we can compare and analyze with historic data and historic events on the system. Now, as the final conclusion, water asset management involves understanding the dynamic system of water and how it reaches the people who rely on it daily. This project doesn't just focus on traditional infrastructure assets. It considers the entire water supply system as one asset. Improving the system can lead to better decisions and investment plans, directly impacting people's quality of life through improved water quality. We were able to improve our 2022 non-revenue water value, and we believe it will continue to do so in future years. Also, the tool's ability to identify the precise length of pipe that needs intervention has also contributed to the estimation of the return on the investment. So, overall, with this digital model that was actually a project that identified the entire water supply system as an asset instead of going pipe by pipe, we were able to accelerate the decision-making process. We know better our water supply system. We have grown the efficiency within the management of our water supply system. We have direct correlation between the intervened mains and the non-revenue water reduction. We have on-time identification of critical assets, and we are guaranteeing the investment of the company by getting the return we must have. Overall, the contribution of the digitalization process involved in this project has improved our water network management and sustainability efforts. I would like to invite you all that if you want to discuss further this project and all of the algorithms and the digital tools, please feel free to address me. And now we are actually 10 minutes before the deadline. I want to invite you all to come to this poll that I've created for the questions and answers, and I'm ready to answer them and to discuss a little bit further. Thank you.
Thanks, Ricardo. So we have actually had one question come in the chat function as well. So if I address that one to you while we wait to see what else comes through. So Giles has asked, given that DMAs and distribution networks have a high level of configuration and valves, how did you handle the volume of scenarios in the modelling?
I'm so sorry, Miranda. Could you actually repeat? I was
Of course I
changing
can.
the screens.
No problem at all. So given that DMAs and distribution networks have a high level of configuration and valves, how did you handle the volume of scenarios in the modelling?
So basically, that was one of the variables that we fed the model with it. We do have all of the metering points and the monitorization points in our GIS, and linked with our system that reads the instant data, pressure and flow data, and with that we were able to replicate the hydraulic model basically.
Thank you. Please do add any questions via the link that Ricardo's got on the screen there. Another one coming through the chat function. Was there any improvement on the overall energy consumption at the pumping stations?
Actually, that's a fail from my description of the water supply system in Porto. We only have one, so the entire system it's a distribution system. It's not like a supply system. Everything goes under the logic of gravity. So that's extremely good for the company since we don't have a lot of costs with energy. And also our drainage, our wastewater system is actually the same principle. So we are very fortunate to have this kind of system.
Just give it a minute more for any. Oh, there we go. We've got another one come through. Does the system direct routine maintenance of non-pipe assets as well as pipe replacement?
Yes. So we aggregate everything on our operational management platform, and we have different symptoms that we call variables. And of course, that every in the company we have specific units and departments that deal with those symptoms and variables. However, we can concentrate and aggregate everything on the model, and actually we can attribute correlations to each specific symptom, and then we measure the ones that have more impact on pipe replacements, and if have or not have a direct impact to to take the decision within the critical asset.
Thank you. Looks as though we've got another one in, but unfortunately I can't see that one on the screen, so I'll leave that one to you to have a look at.
Okay, here it is. Uh, it's actually the second one. We have to make a decision based on the criticality. If we do not have the exact money to spend on all of the replacement of the pipe, we do have to make a decision making within the most critical one. Yes. Normally we don't ask for more money. It depends. Actually, not quite sure. We always take care of the leaks. Attention. We always go to the site and we take care of the leaks. But then we are talking about making renovation plans within the critical assets. So we do know the pipes that have a consistent problem with leaks, and those are the critical ones. If we have to take a decision towards if we go left or right, we do have our variables and we do have our criticality analysis, and then we do the we prioritize.
Excellent, thank you. So another one come in on the chat as well, which is from David Harmon that says, what plans do you have to be able to predict leakages?
Well, as I said before in the initial slides, ADP already has predictive models, and those models are able to give a probability calculus that will identify the DMA that probably has leaks, and then we send teams there to those zones and to those specific streets to look for leaks instantly. Also, we have a direct line within the customers, so any person that sees water in Porto can call us, and we directly go there. But the main results come from that model that every time it senses a variation of pressure or flows, or even has the traffic variables inside. Uh, it it gives an alarm, and it delivers the DMA. Go there, we immediately go there within our staff.
Excellent, thank you. We can move on to the
Okay.
last one on screen now.
Yeah. So the as I said before, the change of idea within this project was that we would not focus firstly asset by asset, the traditional asset like the pipe or the pumps. We were actually looking towards the entire asset that is the water supply system. And within that, now we understand that we can improve a lot DMA's pressure by going adapting within the Porto's terrain. So we are transitioning to creating like little rings that go around the terrain of Porto, and for each specific pressure level, we will have those specific DMAs that will adapt to the natural terrain and natural logic of the water flow. Um, we do have that plan. The model was able to give us the ideal pressure levels, but it will take time and it will take money. So we do hope to achieve that in the next 10 years, and maybe we can even go below our 13 non-revenue water to maybe 10, 5. We are working on it. But every time we adapt our water supply system, GIS, we implement new monitoring points. Everything contributes to this model. This model gives and adapts the new pressure level within our new things that we bring to the system.
Excellent, thank you. We have had another question come in on the chat as well. It says, have you been able to communicate in quantitative terms the consequence of not being able to carry out your proposed plans due to funding constraints, and how does this relate to the organisational declared risk appetite?
Okay, so it's a complex question. I'm not sure if I will be able to answer directly. And also note, please, that I'm a part of this mega project. We're a multi-staff team, and what I can say is that we were very worried about being able to give the visualization of the improvements to our administration. And once we got there, we started to calculate the income of each specific adaptation. And by that, we have made some math within our return on investment for each specific investment. Uh, Investments already made, investment that were planned to be made, and investment that could be made and would translate to more money actually, because the company is worried about the sustainability of the resource that is the water, and we can only achieve that by reducing the volume of losses. And we truly believe that we were able to transmit that to the administration by explaining them that we were actually adapting the system to the natural um, the natural streams, but inside the pipes of the water distribution supply system. Sorry, we kind of replicate streams within our water supply distribution, always guaranteeing, sorry, the pressure level ideal for the city that it's 26.
Great, thank you. We have got one more come in. So, how has future big demand been included into the models, and how do you handle uncertainty in demand the further ahead you analyse?
Couldn't understand the first part, Miranda.
Sorry, it's how has future demand been? It's got. I think it's got a word missing. Been incorporated into the model, and how do you handle uncertainty in demand the further ahead you analyse? So maybe if we just address the second part rather than first.
Yeah. So. as I said, the main objective here and the main goal is actually to guarantee that the model is always updated. Every system information needs to be updated. We need to go and guarantee within every department that deals with a specific system information that they are continuing to guarantee the quality of the data, and that we integrate that within the model, and then we just refresh it actually. Um, so that's the answer I can give to the question actually. That's our way to work. And that's why that I've said on the presentation that I want you to please be aware that the tools and the model do not dictate the decisions. They serve as a data as a service. They are shared within the technicians and the group of technicians, the teams that we have, to better define the investment plan and to better understand which of the assets is critical within the big universe that is the water supply system.
Excellent. We've had another one come in. What were the key risks in the digitalisation project and how they were mitigated or managed?
Yeah. Again, some troubles hearing the question, Miranda.
So, what were the key risks in the project and how were they managed?
Okay, so firstly, we, although ADP had a maturity level in terms of digitalization, we had our information systems, we had our digital management, operation management platform. We had almost everything, but then when we were trying to extract valuable information to our water supply system, we were actually dependent on each specific technician and always an Excel spreadsheet. So the information was not concise, and it was not grouped by. And even though a specific technician thought it was taking the best decision and it was making the best analysis, he never knew that it was dependent on other variables that he was unaware, because he had no platform, he had no model that could correlate all of that. So the one of the biggest keys of this project was firstly to guarantee that the systems were integrated, and then identify the quality of data from our GIS model, from our operational data insight collected within our operational staff, from our customers, and the correlation from the customers with the water supply system. That's a very critical correlation that you must do to in order to understand the complaints, and create a new variable that is exactly that, the complaints within the customers that actually give the money to the company. So that also was an extremely important key. And the third key was that we joined a multidisciplinary team that was not only from the water supply department. We joined efforts within within the asset management department, the water supply department, our GIS department, and our innovation department, our system information department, and we knew exactly where we wanted to go, the difficulties that we would go through, and we started to work on the model and the data, and each step we went, a new analysis, a new idea of a new analysis came, and in the end, the management of the system that has direct impact on the asset management were transformative completely.
Excellent, thank you. And that's all the questions that we've had in today. So I'd just like to thank Ricardo for what I'm sure you'll all agree was a very good session. If you enjoyed this one, why not join us on the 18th of June when Cambo's Razil Carney will be joining us to talk about asset valuation and whole life cost analysis for informed business decision making. So thank you once again, Ricardo, for your time today. It's really appreciated, and thank you all for joining. Have a great day. Thank you.
Cheers, thank you.